Good morning, scientists. These guys look familiar? Well, these are the fish from the classroom, and they're still alive, although they're living out on my back patio these days. You'll notice that the tank doesn't look quite as clean as usual. So why do you think that might be? Well, they are outside, so right behind me over here, there's some trees, and you could see these trees here. The sun ends up coming through, and it ends up shining and hitting right about here. So from here down in the morning, it gets sun. Above here, it's shaded. So the sun has a lot more energy than the lights in the classroom, so we get a lot more algae growth out here. So I've had to do a lot more maintenance on this tank to keep it clean. So I've got to get in there and clean that sometime. So today, we've got a couple other things to do. Your assignment for today is pretty simple. Pretty much all you have to do is you go onto BrainPop and do the BrainPop on the sun. So the BrainPop on the sun, watch the video, do the quiz for practice. It is not for a grade, it's for practice, it's to learn. Hopefully you learn a few more things about the sun and get a little practice there. So speaking of learning a few things, some things to review. We do have a test coming up on Monday. So for Monday's test, keep in mind that the two things the sun is made out of would be hydrogen and helium. So it's made out of dense hydrogen and helium gases. So it's a plasma of hydrogen and helium. Also, we've got the sun has these prominences coming out of this sunspots. You got these big arcs of gas that come out that are kind of shaped by the magnetic field of the sun, and they originate from the sun's photosphere. Think about this. Photo means something you could see. Like if I'm using a camera, I'm taking photos so you could see them. So if you have something that you could see coming from the sun, that would be coming from the photosphere because we could see those things arcing out of the sun. So you could see it, photosphere. Flares, the solar flares, those shoot way out far from the sun, and those increase the amount of radiation that we would expect on the Earth. So when we have those solar flares, they don't happen that often, but when they do, they have to be lined up right aimed at the Earth. So otherwise, we're not going to experience them. Because keep in mind, the sun's a big ball, the Earth is just one little point going around it. So the chances of one of those solar flares lining up with the Earth is pretty low. But that does happen sometimes, and that would increase the amount of radiation on the Earth. Also, know the difference between apparent magnitude and luminosity. So apparent magnitude is how bright a star would appear from Earth, whereas luminosity is its actual brightness or absolute magnitude. On the Hertzsprung-Russell diagram, stars that are hotter are usually brighter unless they're much, much bigger. So you can have a cooler red star that's really bright if it's really big, but for the most part, the general rule is hotter is brighter. Also, stars are classified by two things, their temperature and brightness. So to calculate a star's luminosity or its absolute magnitude, you have to know its temperature and brightness. So for example, if I get the sun behind me over there, to actually calculate its actual brightness, we'd have to know its temperature and then we could, and its brightness, we could classify the sun as a particular type of star. On the other hand, if we're looking at stars and we're trying to figure out their apparent magnitude, we also have to know one more detail, which would be its distance from us. So apparent magnitude is determined by three things: its size, its temperature, and its distance from us. That's how we figure out its apparent brightness or its apparent magnitude. Let's see, stars, the color is what tells us the temperature. So if we want to know the temperature of a star, we need to know the color. So if we see a star and you measure how blue it is, that'll tell us the temperature, or how red it is, that tells us the temperature, or any color in between. Also, when you're looking and comparing the if we're comparing the apparent magnitudes, how bright it looks from the Earth, they give it numbers. Those numbers work in a weird way. The lower the number, the brighter it is. So if you had a star that was like -1, that's going to be really bright in the night sky. If a star was, let's say, 23 or 24, that's going to be much dimmer. So it works in sort of the opposite the way you'd think it would. All right, so that's about it for the review. That's coming up, the test is coming up on Monday for my advanced classes, and that'll probably be on Tuesday for my general science classes. So keep that in mind. Today, your only job is BrainPop on the sun. All right, so stay curious, and I'll see you next time.